Welcome to Study Loop.
This is the answer to Chapter 12, problem number 62 from the Smith Organic Chemistry textbook. And this problem is asking us to synthesize 4 different molecules starting from acetylene each time. And so I've drawn acetylene here at the top. Move it up a little. All right. So that's acetylene up there. And so each of these syntheses, as you can see, starts from acetylene. And they do all have a lot in common. So starting from acetylene, there's really not too much that you can do. So they all start by deprotonating the alkyne. So you would use a strong base for that. I've used sodium hydride. And so starting with A, you deprotonate the alkyne with sodium hydride. You then use this alkyl halide to add this ethyl group. And then that gives you the 4 carbons that you need. And your triple bond is where it should be for when it becomes a double bond. You want a terminal alkene in this molecule. And so you use, you could really use hydrogen gas and Lindlar's catalyst, or you could do a dissolving metal reduction. For this one, it doesn't matter. So I used H2 and Lindlar's, and remember that we'll stop at the alkene oxidation state. And so I've drawn the product here in red just to make it stand out a little bit. And so that's A. So B follows pretty much the same pattern. Deprotonate the alkyne. This time you only need a methyl chloride rather than ethyl chloride. So you add that in. And then you do the exact same thing to the other side. So you deprotonate the other side of the alkyne. You add another equivalent of methyl chloride. And now you have your 4 carbon chain, but now your alkyne is between carbons 2 and 3. And so when you treat this with hydrogen gas and Lindlar's catalyst, you get the cis 2-butene that you're looking for the answer to B. And then so C, rather than rewrite almost all of B, you get to the very last intermediate, where the alkyne is between carbons 2 and 3. And this time, instead of using hydrogen gas and Lindlar's catalyst, you do a dissolving metal reduction. That gives you the trans alkene instead. And so you get trans 2-butene. And that's the answer for C. And then for D, D's a little different. So you deprotonate the alkyne again. You use this alkyl chloride, add it in, do the exact same thing again to the other side of the alkyne. So now you have this symmetric molecule with the alkyne in the middle, and you just treat it with hydrogen gas and palladium on carbon. It will completely reduce the alkyne to an alkane, and that gives you the molecule that you're looking for there. And that is the answer to problem number 6.